So we've taken a look at a couple of examples that deal with finding length based on the angle that is given on a right angle triangle. This time we're going to be taking a look at a couple examples of how do we find an angle given two side lengths. We start off doing the exact same thing that we did before, and we start off by labeling our sides. This one is the hypotenuse. It is the longest side. This one right here is beside. So theta is the angle that we're trying to find. And so this one's right beside there, or it's touching there. So we're going to call that the adjacent, or it is called the adjacent. And this one is going to be our opposite. So we're going to label our sides to solve for that. Now you will notice that we are given the opposite and adjacent sides. And the trig ratio that has those two sides is our tan function. So our tan function has the opposite and adjacent there. And so tan theta is equal to opposite over adjacent. We should always get the two sides that we are given in our function. Then to solve for it, and this is where it can, well, this first part shouldn't be too tricky. It should be fairly straightforward, and I'm going to say fairly straightforward. We plug in our values. We don't know what theta is yet, so we're going to leave that as theta. And our opposite is 7, and our adjacent is 10. Now, just to give you a little bit of a reminder, I went through this in the last video really quickly, but if our adjacent is longer than our opposite, we will have an angle of less than 45 degrees. If our opposite is bigger than our adjacent, the angle will be greater than 45 degrees. So that's something that you can kind of think about, and it might kind of help you out with when you're solving these types of questions. Now, how we need to solve this is we need to recognize that we want to try to find theta, and so we need to get rid of tan. The way to get rid of tan is to do the opposite of tan, and that is tan negative 1. So if we do tan negative 1, or the inverse of tan, okay, so it's important to recognize inverse of tan. Usually on your calculator, this is the second function. It should be something that you went through last year. If we go through and use the second function, that will give us inverse. That's the opposite of tan. And so the way that we're going to write that out is that theta, and now I'm going to get rid of tan right off the bat, I've already left it, is equal to the inverse, which is just tan negative 1, of 7 over 10. Get outside there. Okay, of 7 over 10. Now you could, the way that I would recommend that you do this on a calculator is to, just get theta in here, would be to do what's inside the brackets first, and then do second function of tan. And I'm going to go through using the calculator and just show how I would do it. Let's go here. Maybe I'll just do it later. Okay. All right. So to do this, what we're going to do here is we're going to do 7 divided by 10 equals, and we get 0.7. And then in this case here, I have an inverse here. Normally it'd be a second function, and we'll do second function 10. Oh, that didn't work. Okay, let's try that out here. Okay, inverse tan of 0.7, or I should be, or here, you know what? With mine, I can actually do this here. I can just do answer and equals, and I'll get an angle of 34.99 degrees in many cases. And this will be one we're going to usually round up to the nearest degree, but we can kind of think of, so this would be like 34.99 degrees, or if we round up to the nearest degree, it is 35 degrees. Okay. So this one would be 35 degrees. Normally, I'm just going to tell you to do to the nearest degree. If I do say to 2 decimal places, please do 2 decimal places, or the nearest tenth would be 1 decimal place. But for the most part, we're going to just do to the nearest degree. So 35 degrees would be to the nearest degree. Let's solve for the next one here. Here we are given a different letter. Instead of theta, we're given the letter beta, which is another Greek letter. These are just ways of saying this is the angle, or trying to find the angle. And so it really is the same thing. It's just given as a different angle. All right, first thing we're going to do, we're going to label our sides. We have our adjacent right there. We have our hypotenuse right here. And so that means that this side is our opposite. Now, given that we have the adjacent and hypotenuse, that means that we're going to be using cosine, cos of theta is equal to adjacent over hypotenuse. And so now we plug in our values. I'm going to try this new color here, see if that works for you there. And I'm actually going to simplify this right away. I'm going to do the inverse cos right away. So we're going to do theta is equal to cos -1 of our adjacent, which is 8, and our hypotenuse, which is 17. So I right away converted it strictly to our inverse cos. This is the way that we can think of solving for an angle. Anytime we need to solve for an angle, we do the inverse of whatever function we have, and then we put in our ratio inside of the brackets. The ratio is just the fraction of the two sides. So if we solve this here, let's get our theta in there. Theta is equal to, and so what we can do as well is we can do inverse cos, there, inverse cos, and then inside the brackets, I'm going to do 7 divided by 7, or sorry, that was 8 divided by 17, close brackets, and I get an angle of 61.93 degrees, or 62 degrees. Okay, so it'll be this should be to round to the nearest decimal place, or sorry, nearest whole number. This would be to 2 decimal places as to how to find it. So this is solving for the angle. Again, for some people that might be fairly straightforward. For others of you that might be a bit of a challenge. Okay, ask questions because we need to make sure that we understand how to especially do the inverse part, because we're going to be using that the entire unit. How do you do the inverse to solve for an angle?